Web search. Web search is the key to getting the latest information into the model, no matter what the topic area is. With web search, the user can ask the model for its interpretation of the events of the last few days. Otherwise, you're stuck with the info that the model learned when it was trained, or what you added with RAG. But models can't search the web on their own. None of them can. Anything that offers that has added that functionality in the software that wraps the model. I'm Matt Williams, and I was a founding member of the Ollama team. I've since left the group to develop my own YouTube channel, where I focus on helping folks understand all the different types of local AI tools. I believe the easiest and best of the tools out there is Ollama, and I want to see it succeed. You can find out more about Ollama on their website, which is ollama.com. In the middle of the page is a large button to get you started with installing it locally for you. Okay, in past episodes of this training course, we looked at a technique called RAG, or Retrieval Augmented Generation. This method took your initial query to the model, embedded it, and then compared it to all the contents of a vector store looking for similar content. It then fed all these results plus the original query to the model, which could then generate a response that's very specific to the knowledge stored in the vector database. It's an amazingly effective method to use, but it only contains the information you or someone else put into the vector store. For web search, we basically do the same thing, but it does require an extra piece of software to provide an API that spits out the search results. And it needs to access a publicly available search engine like Google or Bing or others because they have the search content. And this presents a bit of a problem. A lot of folks get into Ollama because of the massive privacy and security benefits. But if you have to use Google or Microsoft or DuckDuckGo to get search results and to stay in business, all of them have had to use search data in sketchy ways, then haven't you lost the benefit? Well, hopefully the search API you use can obfuscate the user from the request, making it much more private. If you use the API provided by Google and Microsoft directly, you don't get that. But if you use another tool in front of that, maybe you can. The tool I like to use is called SearXNG, though it's spelled SearXNG. It's what's referred to as a meta search engine, which allows users to search multiple search engines at once and filter the results through their own preferences. Any personal info is extracted from the request before it's sent, and the actual search engine doesn't know anything about you. There are a few ways to use SearXNG. You could use one of the many searching providers out there, though that means you have to trust the provider to not do something with your data. Another is to host it on your own machine. It's available as a Docker image, so you can run it and get it up and running in almost no time. Now, I actually prefer to run it on a host outside of my home network that I already use for hosting a number of things. It's a cheap instance on DigitalOcean that works really well for me. There's also a Docker Compose file if you want a more production-ready instance for others to use as well. And then there are compose files made by others that make it easier to theme searching. So with all that configured, I can start using SearXNG in conjunction with Ollama. Essentially, the steps are as follows. First, get a search query from the user, send that back to SearXNG, and get back a list of URLs that talk about the topic of interest. Fetch the pages at those URLs and do a bit of cleanup to get just the relevant text from the page. Then send that original query and the fetched cleaned up web pages to the model and have it answer the question. You could go a bit further and maybe add a page to a vector store, making later searches faster along with some other benefits. Actually, there's a lot you could do here to improve on these basic concepts. Let's take a look at what this is like. I'll open up the news app on my computer to see what's going on right now in the news. It seems there's a dock workers strike. There's no way a model would know anything about it, so let's ask the app to tell me about it. First, it finds relevant resources, pulls them down, cleans them up a bit, and then Ollama answers the question using that info. I also see Iran is in the news, so let's ask for a summary about that. And there's a quick summary. And there's a new president of Mexico. Tell me about her. If you find videos like this interesting, please consider liking and subscribing. I am eagerly working on getting my first 1,000,000 subscribers, and your support could help me get the next 965,000 subs that I need to get there. So these results are pretty great. Now let's take a look at the code. It's written in TypeScript, though it should be pretty easy to follow no matter what language you prefer. There are a couple of import statements at the top, and then I set a couple of important constants. And then here is basically the entire app. Print out the query, get all the URLs from the searching API for the query, then get all the cleansed text from the URLs, and finally get the answer from Ollama. So let's take a look at the functions. First, get news URLs. I pass in the query and then fetch a JSON object with the results from searching. I only really care about the URL, so make a list of all the URLs, then slice it to grab just the first 5 and return that list. Okay, so the next function is get clean text, which takes that list of URLs, fetches the full HTML, cleans it up, and spits out the array of text. Now, the actual cleanup of the text happens in the HTML to text function. There are probably better ways to do this, but since I just need the text and I don't need to make it pretty, I use Cheerio to load the HTML and delete anything that isn't useful text, like get rid of script and style and image and form and iframe elements and others. Get rid of classes and any data attributes, and then just get the text and remove the extra white space, and then I return the text. Cheerio is a pretty easy to use library that lets me do all sorts of things with HTML. It seems to be a subset of jQuery, but for Node.js, and it's pretty awesome. So now we have all the text from all the web pages in one array. The answer query function takes those and the original query and generates an answer. You can see I'm using the new Llama 3.2 model at only 1 billion parameters, and the answer is streamed out as it's generated. And that's it. You can find the source code for this example in my GitHub org. Go to the repo video projects, and then there's a folder with today's date, which is October 1st, and then Websearch. I use Dino for this project, and you can find out more about that at dino.land. V2 of Dino is coming out any day now, and I am super excited about it. What do you think? Do you see how you could incorporate search into your own apps that use AI? I think this is pretty powerful stuff, and once you set up the platform, integrating search results is incredibly easy. Have you done anything like this? I would love to hear more in the comments below. Thanks so much for watching. Goodbye.